So hello everybody. I would like to start with this talk with a quote from the British anthropologist Tim Ingold. In this quote, Tim Ingold tries to present the tension between the very rational side of science and the never-ending search for truth, and a more let's say creative and with more feeling side of science, with the wonder and astonishment. And what Tim Ingold says is that we need maybe to rethink a bit about how we conceive our research to take into account this kind of both sides. The thinking of Tim Ingold has been very influential over the last decades to the development of the relational turn of science, which has been developed in many different fields like physics, philosophy, and also, of course, environmental sciences. And this relational turn of science tries to open up the definition of science to include ways of knowing that are subjective, like the connection to body, the senses, the mental representation, and other stuff. And it tries to, most of all, to erase the dichotomy between human and nature, between rationality and emotions, and tries to take into account that nature really includes some empirical experiences that most of the time we don't really talk about this in our science. And it really focuses on the dynamic relations between the mind, the body, the culture, and the environment. So really what the relational terms try to stress is that we need kind of embodied engagement and responsiveness between all things, the human and the non-humans. And this way, we can lead to a holistic representation and understanding of our study subject and of the Earth. What is really interesting in this relational term is that entities are not really beings. There are really complex and evolving relationships among humans and non-humans, and they are considered not really as beings, but as events, movements, and processes rather than independent. So I'm going to try to show this on this beautiful landscape in the tropical Andes with the Cotopaxi on the background. We can spot different entities here in the landscape, like the glacier, maybe a stream in the valley, the plants, a rock sheltering the plants and other entities. But really what is interesting is not really the glacier, but the melting glacier, for example, not the stream, but the running stream, not the plants, but the colonizing plants. And this kind of action that we put with the entities allows us to link the different parts of the ecosystem. The melting glacier goes with the flow, and maybe the wind, the blowing winds, goes to the dispersion of the plants. So this is a bit the holistic view that comes into play when we relate the different entities. But what is really important in this holistic view and in this relational term is that we also include the perception that we human have in this landscape. Maybe when you see the landscape, you don't see it as a socio-ecological landscape, you don't see any social part, but actually everything that you see through your eyes is influenced by your own perspective and your representation. In the holistic part, holistic view, it's also important to go back in time or to go further in the future. I mean, to connect different spaces in terms of time, and also to connect different regions. So today I would like to present you a kind of analysis of the holistic view of climate change in the Andes. And to start with, I would like to start with this representation of the Andes, which is not the common representation that we have in most presentations. It's a better representation because the Andes are really long mountains, so it's better to fit in the screen when it's put this way. Jay Hart is the American artist who drew this this map. We don't really know, he tries to challenge the viewer, and we don't really know why it is. The orientation is very different, maybe because in the medieval times, actually the maps were oriented this way because it was thought that in the east, where the sun is, there is also God and all the creation of the world. And also the colors are a bit different. We are used to have the whites on the top of the mountains, and here the mountains are pinkish. And Jay Hart explains in the legend of this figure, it is to represent the oxygen deprived zone high in the mountains. So we can see that the artist tried to combine the data, the scientific data, and the representation of the Andes. So today I would like to talk to you and to present you 3 stories in the tropical Andes. One about flowing stream, the other one with climbing plants, and the third one and the last one about greeting bears. So let's start with the first one, flowing streams. more than 15 years ago now in Ecuador, just in face of the Mountain Tizana, for those who know Ecuador, we had this kind of fabulous spectacle with my friend Dean Jacobson. We saw these two streams. One is a glacier-fed stream, the other one is a rain-fed streams, and we saw this confluence of the stream. And once we had seen this, many questions popped up in our mind, because we are ecologists. And so what are the difference in diversity and different types of streams, and how what is the influence of one stream on the other one, and what will happen if there is some higher discharge of the stream, or glacier melting, or retreating of the glacier. So that was like a view from a scientific point of view, from an ecological point of view. What is interesting is that the confluence of streams have also inspired other kind of minds, and especially artists' minds. And this is I would like to show you this story of Brady Smetana, who was a Czech composer at the end of the 19th century. And he wanted to create a music to tell to all the people over the world about his country. And he wanted to make a music about the main river, the Maldor River, that runs through the country. And he went to the spring of the river, and he found two springs in the river. And you can see here the two springs. One is a kind of warm and gushing, and the other one is color and peaceful. And he wrote a music about this. So what you can hear with the flutes is the first side of the stream. So these flutes represent one of the spring. And now comes the clarinets. And the clarinets are the other side of the stream, the other branch of the stream, which is different, and it has a different melody. And what you're gonna hear now is they kind of converge, and you will only hear one flute in total. So here it's only one sound. And then you arrive at the confluence. So this kind of dramatic music, the melting of the water, and then the big flow with the viola. So what is really remarkable is that he composed his music even if he was deaf. So it's really a kind of amazing achievement that he could do with this kind of landscape. Another experience that I have directly with an artist was with Ricky Chagar. Actually, he contacted me like 1 year ago after he had read one of our papers we published on climate change and in the Bolivian Andes that we co-authored also with Dean. And actually, what he did is that he thought about climate change in the mountains, and he tried to put different entities with the different instruments. So for example, the flutes are the birds. The celesta is the icy environment of the glacier. And you can see a kind of peaceful melody, which is the pre-state before climate change. The opus is with different pieces, and the first pieces is the kind of the environment. And then now we go to the climate change, and you will hear the rumbling bass and the cymbals to show the effect of climate change on the system, and the escaping animals because of this chaos. So for me, it was a kind of very impressive experience that someone could read my paper, our paper, and try to translate the data into music and have a different experience and perspective about climate change. Another perspective also is done by this Mexican artist, Loretta Castro-Reguera. And she had a kind of incredible achievement because she drew all the confluences of the stream in South America. And she did it, for example, for the Amazon basin. So she drew every kind of stream, and there's more than 1,100 streams in the headwater of this huge watershed. And what is really interesting here is that we can here spot our two streams because they are part of the Ecuadorian basin, of the Amazonian basin, and this confluence is very important and at the top of this basin. And I would like to compare this with another place in the same basin, but which has a kind of similitude with this one. Here, this is the confluence between the Rio Negro and the Amazon, and you can see here some kind of resemblance with what we observe in our stream, with the same kind of two waters with a different temperature and a different texture, and you can see the stream running side by side and then mixing up. And what is interesting here again is to see the different views that people have on this really wonderful spectacle. So one scientist, hydrologist Bob Mead, for example, talk about the greatest hydrologic spectacle on the planet, and he compares the different color of the stream with the cafe au lait color waters, and the other one is a black tea color water. So it's really a lively description. If you go, for example, to Humboldt, who went there also with La Condamine or Wallace, Humboldt talk about an old man, an old indigenous man who could feel and taste the different water that he could find in his environment and tell you what kind of water it is, if it is a black water, brown water, a mix about the two waters. And also another paper that was really inspiring when we saw this confluence in the Antisana and we try to think about other places, were these papers about the ecology of electric fishes that really show that after the confluence, you have an increase in fish diversity. And so we thought that maybe that could be an interesting hypothesis to study back to the Antisana. So here we're back to the Antisana. Here there is a kind of animation where you can see the retreating glacier over the different decades. It's more or less about 10 meters every year, the receding of the glacier. And you can see here the different streams coming on the watershed, with the blue streams, which are more like spring-fed fed, and the gray streams that are fed by glacier. And what we did first is to characterize the hydrology of the streams, and we use some kind of beautiful graphics of wavelet analysis to show that actually we had this kind of very 24 hours period. So you can see here in the Andes, because we're on the tropics, you have this kind of daily respiration of the stream. It's a kind of it's an imagination about what the stream can be, but you can see really this kind of respiration. And what was interesting is that thanks to this methodology, we could see that the glacier was impacting not only the streams that are coloring gray here, but also other small streams like this one, for example, that has actually an influence from the background, from the ground, thanks to, and we can see the signal here. We went further with Dean Jacobson on this stream, and we then realized that the data that we had after the confluence really confirm what our previous investigators showed in the Amazon basin. Actually, when you see here the diversity of some benthic invertebrates in view of the glacier covering the catchment, you can see that with about between 25 and 11% of glacier covering the catchment, you have an increase actually and a peak in diversity. So these glaciers are really important, not only to provide water, not only to have some specific species in the very endemic species in the very glacier stream, but also they increase the overall glacier watershed biodiversity. Then what we did is to try to have fun. We get back to our childhood experience, also with this more emotional side, and we build a dam on the stream to try to mimic what would happen if you have a decrease in the flow of the stream due to the glacial retreat. So we diverted, you can see here, we diverted more or less 2/3 of the stream to leave only 1/3 of the stream, and we observed this over several years to see what would happen. And what would happen, what we could put into what we could see in the data is that during this experiment, we shifted the stream from one state that was a state with low algal biomass and biomass of herbivores, benthic herbivores, to another state which was higher level of biomass, chlorophyll, and also of invertebrates. And actually, we did it in different streams, and we saw that there could be actually a tipping point at about 10% of glacier covering the catchment, and the stream that received less than 10% of the water and glacier in the catchment would experience this kind of shift in states. So to end up with this first part, when we talk about flow and stream, it's not only about hydrology, or it's not about the home for life in the stream. It's also about the branching pattern, the musicality, the distance influence of the stream, the childhood experience, the taste and the color of the stream, and the different stories and imagination that goes also hand to hand with the data and the prediction that we could do in this place. The second story is about climbing plants. And as you know, plants and many organisms, animals and plants have been released studies to document climate change in the mountain. This is the review paper that was published a couple of years ago, where you can see that the different organisms and how they locate themselves when compared to the isotherm shift velocity. We will be more interested here in alpine plains. Here they are. And when you talk about climbing planes or moving planes, actually, it's not only a natural phenomena, for example, with the wind or with the work shelters that are really important for the establishment of the plants, but it's also something that deals with human, for example, tourism can have an effect of disseminating the plant in the mountains, tourism, and also recent papers have shown the importance, for example, in the Andes of camelids that are held by people here in the high Andes, and they can also increase the, for example, the nutrients in the soil, and they can increase the colonization of the plants. So colonization of the plants is not really social, it's not really natural, it's a kind of mixing of the two, and this is because of this relational ecology that we can think about this. Of course, when you talk about migrating plants in the Andes, you think about what Humboldt did more than 200 years ago when he published his Tableau Physique, where he used the shape of the Chimborazo to represent the different species of the plants here on this altitudinal gradient. What is interesting with the Tableau Physique is that it combines a lot of data about chemistry, about physics, about people. So it's a kind of very holistic view of the place. And also what is interesting is that what you can see, for example, here in the Chimborazo is that Humboldt put some data from other places. For example, he put the altitude of the Popocatépetl, which is a volcano in Mexico. And also he put some events, for example, here, hauteur du Mont Blanc à laquelle Monsieur de Saussure est monté en 1787. So he talked about the Saussure and the ascension to the Mont Blanc in 1787. So he relates to the past, he relates to other places, he relates to other people, and this is really the holistic view that he had. It was so holistic that this Tableau Physique inspired a lot of people. He inspired, for example, Friedrich Schurz to paint his Heart of the Andes, which is a very interesting painting because there is at the same time the kind of emotion of the painting, but also the description, very fine description of the plants along the altitude gradient. Actually, you can see on this painting like more than 100 different plants, and to see it, actually, you need some binoculars. This is my son here at the Met in New York, and when Church came out with his painting, he asked people to come with opera glasses to see his painting. So it's very interesting to see how it could mix the scientific views, like looking at the details, and at the same time the emotional views of seeing a painting. So the Chimborazo of Humboldt has really, it is really a myth in ecology, in art, in many different disciplines, and this is a myth that we keep on talking about. And in this book that I'm sure you know about Andrea Wolf, she continued to convey this myth of the Chimborazo and describing, for example, Humboldt like having a kind of haha moment in the Chimborazo and seeing all the biogeography and all this stuff. So it's very nice to see it. But when you look at the cahier of Humboldt, at the notebook of Humboldt, sorry, the situation is very different, because when they climbed to the Chimborazo, the weather was really bad. It made everything impossible. He couldn't measure, he couldn't collect any plants. The visit of this immense elevation was exceedingly depressing and gloomy. All the nevados who visited Chimborazo possessed the fewest plants, and in addition, a vegetation without vigor, not adapted to the beauty of this colossus. So actually, Humboldt had this Chimborazo because it was the highest peak of the world at this time. But in terms of ecology and in terms of what it gave to science, it's very poor. And actually, what we did, working with one of my colleagues, Pierre Moret, who is an historian at the University of Toulouse and CNRS, is that we realized that the tableau physique of Humboldt used it to make his thinking about the ecology and biogeography of plants evolving. You can see here the table, the tableau in 1807 and in 1824, and you can see that the label of the plants really are not at the same altitude, because the name of the plants were shifting, and because also when he looked back to his data, he saw that there was some adjustment to do on his table. So we have to see the tableau physique not only as something which is very scientific, very with data, but more about something to think about, and in which we're going to put all the experiences, the scientific one and the emotional one. So because the tableau physique is a bit a big mess, it's very hard to use this data to know about the change in the shift and the elevation in the shift in elevation of plants since Humboldt. This is what we wanted to do. So we came back to the Natural History Museum library in Paris, and we discovered this notebook by Bonpland, who was the friend and the companion and also the botanist of the expedition of Humboldt. He was collecting the plant, and he did something really really great, is that for each plant he put a number. Here you can see the number is 2,244. This is this Culsitium nivale, one of the plants, and this number was also in the elevation data by Humboldt, and it was also in the herbarium. So this was really the code to relate the different plants with the different altitudes. And thanks to the notebook by Bonpland, we could see where they collected all the plants, especially in the mountains, where we were interested to document the shift in elevation, and what was the elevation of the plants. And what we realized is that most of the plants that they collected in the tropical Andes were collected not on the Chimborazo, but really on the Antisana, which is another mountain. Here is our team with Dean here in the foreground. And actually, once again, when he presented the Chimborazo, you can see here that on the Chimborazo, he drew the hut of the Antisana, which is a refuge that is at the foot of the Antisana. So for Humboldt, really this holistic view made him combining different times and different places on a single representation. And we had to think about this kind of holistic view of Humboldt if we wanted to crack the code to be able to document the shift in elevation of plants in Ecuador. What we needed to know also is which was the trail that was taken by Bonpland and Humboldt when they climbed to the Antisana. And when you look at the mountain, and Christian Körner, this is a very nice drawing. Here, when you see the mountain here as an altitudinal band, no matter which trail you take, you will always have the kind of same band. But the reality of a mountain is more like this. So depending on the trail that you have, you can see that you will pass on different microhabitats and micro places that can influence the distribution of plants. So you need to really know the exact trail of the explorers if you want to get back to their footsteps. What is really interesting about this, and to go back to time too, is Louis Raymond de Carbonnière, who did some pioneering study in plant botany, in plant ecology, sorry, in the Pyrenees. And you can see this drawing, which dates back more than 200 years ago from the paper of Christian Körner. And you can see almost the same drawing, where he drew really the microclimates and the different shades in the mountains and how he could influence the plants. So we didn't really invent a lot of things this last day with the microclimate. It was already done like centuries ago. What is very interesting in this is that the importance of microclimate, you can see it through thermography. And thermography is an interesting way of thinking about climate change, because it can visualize in some way the climate change, and it can visualize the challenges that face plants and other organisms to face climate change. And I would like to share with you this video about some testimony of investigators in an exhibition that was about thermography, about climate change.
It's been taught for a while that you should remove emotion.
All of our experiments are designed so that you must stay objective.
We kind of keep ourselves separate from the emotional consequences of some of the things we work on. I think that's a defense strategy.
But we all chose to do this for a reason, and I think we have to acknowledge that we are emotional beings, because if we don't, we actually introduce bias into our experiments by not recognising that we have emotions.
Most scientists are incredibly passionate about what they do, particularly in environmental sciences. what usually drives us is this need to understand, but also a need to make a difference.
It's important that science gets to the truth. It's not someone's opinion, it's actually reality. Where that runs into problems is if you as the scientist have to be unemotional, how do you explain to someone how serious the problem is without showing that you care about this problem?
So once again, they were talking about this tension about data and rigor of science and the emotion, and so going back to what we can do here to follow the footsteps of Humboldt and Bonpland climbing the Antisana and to try to document the shift, do we have any clue about where they went and what is the exact trail? Actually, we do. We can find back data once again in the notebook by Humboldt, where he described very precisely what are the places where he went, the Antisana hut, for example, and other stops that he had on his way to the Antisana. And what is interesting is that he talks about a cave, a hole in German, and the idea was to try to find this cave because it was a very important point. That was the last point, the last at the highest altitude where they sampled plants, and this is the place where they say they found the last growing plant. So we really had to find the cave. We explored this side of the Antisana for several weeks, and our team here in the Catholic University, led by Priscilla Muriel, who is the head of the herbarium here at the Catholic University, they really had some luck to find the cave. So that was a really emotional moment, because going to the footstep of Humboldt in Chimborazo in Antisana is one thing, but being really at the very place where they stood up like 200 years ago, because the cave is about 2 meters, 2 meters width. So I was even looking for some remains by Humboldt. Maybe he forgot something, and maybe we could take some kind of stuff from him, but there was nothing there. But it was a very emotional part, and when we measured the altitude of the cave, it was the exact altitude that was in the Humboldt notebook. So it was a very great discovery. So thanks with this cave, we could redefine the 4 different stops where Humboldt and Bonpland collected the plants, and we could collect the plants more than 250 years after, and really try to document the shift in elevation. So here in red you have the plants and the altitude at which they were sampled by Humboldt and Bonpland, and here in blue you have the ranges of this plant nowadays. Actually, you cannot say that even if they, for example, sample this Lysipioma here at 4,100 meters, they didn't find it further up, because once they have collected the plant, they didn't want to collect it maybe a second time, because they had a lot of plants in their baggage. So the idea that we could only really rely to know the shift on the last plant, the plant that was on the cave, that was this Senecio nivalis, and we can see that now the Senecio nivalis can be found more or less 200 meters higher in altitude, which is about the velocity of change that we can observe in the plants elsewhere in the year. Okay, so when you talk about climbing planks, once again, it's not only about only the colonization of a new place, it's about the aesthetic, the different maps, the archives that we need to go, the mentalization about how Humboldt and Bonpland was following their way, the maze of the past relationship, because it was kind of hard to find the different clues, the wind, the camelids and the humans, and the thermography that make the link between the hard data and also the more emotional side of data. Now I would like to talk about grazing bears, which is the last part of my talk. And actually, when we published this paper with Dean in Nature Climate Change more than 10 years ago, I was contacted by James Painter. At this time, James was a journalist in Oxford at the Institute for Climate Change. He was there was a great deal about climato-scepticism, and he was fighting against this. So he wanted to make a story about what we did. He was really impressed by the confluence of the stream, but really he was a bit skeptical about the power of our macroinvertebrates, because we're working on kind of ugly larvae in the streams. You can see some represented here, and he was trying to make it a bit more lively. So he said we could say that these invertebrates are the polar bears of the high Andean streams. So this led me thinking about how I could also translate the study that we did and the protection of these high mountains to the large public. The flies are not really good candidates, so I turned to the bear. And actually, we have a bear here in the Andes in in Ecuador and in other countries. And interestingly, this bear was named by Frédéric Cuvier, who was the head of the menagerie of the Jardin des Plantes in this time. The bear came from Chile, even if there are no bear in Chile, but the boat was coming from Chile and the bear was coming from Peru. He died during the transport, and Frédéric Cuvier wanted him to live because he was observing the animals. But actually, he was very sure that it will happen with the species what happened with so many other. Once indicated, the travelers will go there, and soon enough we will have a complete natural history of this bear. And actually, he was completely wrong, because more than 150 years later that the bear was named, really we knew almost nothing about the ecology of this bear. We thought that there were 2 bear species, maybe 3. It was a big mess. And the first paper of the bear was published only in 1980 by Bernard Peyton, where he described in Peru the ecology of the bear. So what we know briefly about the bear, it's a very interesting one to talk to the public, not also because it's the only bear here in the Andes, but because also it's a very it's a bear which is distant from the other bear species in the tree of life. You can see all the Ursidae species, and here this is a Trematonidae, which is more the short-nosed bear. Also, this is the closest relative from the giant bear that once roamed South America, and that was more or less like 3 meters height. And the distribution also is very specific from the Venezuela to the north of Argentina. But the bear is very interesting also to mix this kind of very scientific fact and also all the emotional and all the mythological and cultural aspect of the animal. So here you can see in Oruro in Bolivia, the bear is still a very important character of the Diablada, which is a dance during the carnival of in Bolivia. And you have also these ukukus, who are the man who make the connection between people who climb to the mountain to take a bit of ice. Now they only take water, and the spirit of the glacier, and the dance, and they take this kind of communion with the glacier is thanks to the ukuki, who is like dancing all the time. And you can see here on this table all the different names that the bears were given by the different communities here in the Andes. So that is really culturally very important to define what is Andean in the Andes. What was interesting is that I was trying to take a picture of this bear this is one of my, I'm kind of fond of taking wildlife photography. So I was saying, okay, can I take a picture of the bear in the Paramo just to show this connection that we have with the bear between human and non-humans, to convey this sense of respect and conservation of the Paramo. And once again, when you read the notebook of Humboldt is talking about the bear, not directly on the bear, but because he was eating a puya, which is this plant that the bear feeds on. And actually, if you want to look at the bear in the Paramo, it's kind of very hard to spot the small black spot in the Paramo, but it's much easier to see it even if you're on the road, and if you're at a distance, you can see these white spots, which is what is left by the bear when they feed on. And what they do is that they feed really on the heart of the puya. Here you can see a mother, and here you can see the little cub here waiting for his mother. And they really feed on this, and they can feed also the young with the puya, and that's what the kind of interaction I would like to show people, like maternal, because the bear is a kind of very symbolic. It resembles us. I mean, it can be on 2 legs, and it can feed on salmon and honey and corn, everything that we like to. So there is kind of resemblance, and I would like to make this connection. And I had the chance to take the picture that I think could make the connection with the bear. So actually, I was climbing after the bear, and after a short moment, I could spot this family of bears, and I was here with my camera, and I was taking pictures, and the little bear was hearing the click of the camera, and he was playing with his brother, and at the end he came with a kind of wave like this. That was really a true connection on this. What was really interesting here is that we published a book on the different pictures, and we did this with the FONAC, which is the water fund here in Quito, and also the big municipality enterprise for potable water. And we could do a kind of commercial advertising campaign about the role of the Paramo, which are these kind of great pig bog giving the water to Quito, with the pictures, and try to go to this very interesting dynamic of putting the bear as a symbol of climate change, of protection of the mountain, and of the protection of the water. And one story which is very interesting about this, and that relates to the polar bear. The polar bear is the kind of symbol of climate change all over the world. And it's funny because here in Ecuador, you have this kind of very famous water, the Wittig. When you want sparkling water in Ecuador, you don't ask sparkling water, you say, I want a Wittig. And the Wittig, the label of the Wittig for 50 years has been a polar bear. We don't really know why, but because it was like refreshing. But after 15 years, they didn't have the brand anymore. They couldn't use the brand anymore. So they had to think about another symbol to represent the water. And because there was all this dynamic about the Andean bear, they said, okay, we're going to put an Andean bear on the label of the bottle. And you can see here what is supposed to be an Andean bear. You can see here, it looks like where there is a den, it looks like more a brown bear. There are the spectacles, so it's okay. But it was very funny because Luis Suarez, who is the pro, the guru of Andean bears here in Ecuador, he just spotted that it was kind of very weird bear. And actually on Shutterstocks, he found this true grizzly bear. And the designer of the label just took the grizzly bear, put it on the label, and just drew some spectacle around the eyes. So that was really something that made the buzz on Twitter and all the social media, saying it's impossible. We need a true representation of an Andean bear. You need to involve the Ecuadorian artists and blah blah blah. And what was very great about this is that thanks to the book and thanks to all the campaign about the bear, we could have some very nice label about the Andean bear. And now this is an Andean bear which is on the label of the Wittig. So here again, when we talk about greeting bears, about the bears, it's about water cycle, it's about the spiritual bond with the water, it's about the perma-conservation, the citizen, the excitement of seeing the bear, and all the Andean culture, so we can have this kind of holistic view. Okay, so I come to the end of this talk. The take-home message for me is that really, as you saw in my talk, the network of the past relationships in a system is very important to understand how a system works today, all this kind of holistic view, including the past. At the end, the knowledge that we have on one place is really a product of our practical engagement in the world, and it is really situated in different places. Chimborazo is not the same than Antisana, and it's very difficult to do all these kind of global approaches. We need some more situated approach and plural approaches also. The translational approach makes previously under-acknowledged and undervalued aspect of the world visible and valuated. This is all the hidden story that I told you about, all the music, all the ukukus and all these stories. And I think that we need to shift really from seeing the nature as a system for interdisciplinary scientists, because we have all this big theory about socio-ecological system. But at the end, what we do is to try to model and manage this common good and we need to shift to mountains more as an object for moral instruction for people, and also aesthetic appreciation for every individual. So every individual that goes to the mountain has to see this kind of thing. So this is the final picture. It was taken by Dean Jacobsen. Once again, I'm here in front of the Parmo, and well, maybe it seems to you a bit esoteric, but now when I see a landscape, I don't see really as I was seeing the landscape before as an ecologist, only with like the natural features, but I could see all the mythm, all the stories, all the ukuku, Humboldt, and all this stuff that really give the place a very different story. It's not only about what I see, but it was about what is hidden, also all the stories that are hidden. And I think that really this kind of translational shift that we can have in ecology and in other science is very important for the conservation of the mountains. And it's very important because we need it because of the urging climate change, and also because there is no planet B. Thank you for your attention.